This is the example video for A2 graphing linear equations. Okay, so for this first example, we have an equation where y is isolated. So we have y equals mx plus b. So this is a slope-intercept form equation. So I know my b is -2, so that's where I want to start. So from 0, I'll go down to -2, make my first point. From there, my slope, or my rise over run, is -3/2. So instead of going up 3, I'll go down 3, -1, 2, 3, and over 2. And because I'm running out of space on this portion of my graph, I can go up 3, 1, 2, 3, and to the left 2, 1, 2. And one more time for good measure. So we go up 1, 2, 3, and over 2. Now I can draw one line connecting all of these points. Okay, perfect. So my next example over here, again, y is isolated, it's by itself. So it is in y equals mx plus b form, also known as slope-intercept form. So I'll start at -3. And my slope is just 2. So 2 is the same thing as 2 over 1, so I know my rise will be 2 and my run will be 1. Your run will always be 1 if your slope is a whole number, such as this. So we'll go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Now I'll make a line that connects all of these points. Pause the video if you need more time. Okay. So for this example, we have our y and our x on opposite sides, but our y is not isolated. And we have some parentheses here. So we know this equation is in point-slope form. So I know I have to distribute my slope. So I have y plus 1 equals 1/2 x plus 1. Okay? And what I want to do, my goal when I have an equation in point-slope form, is to get it in slope-intercept form. So I need to get y by itself, so I'll subtract 1 from both sides. 1's cancel, so I'm left with y equals 1/2x. And then those 1's cancel. So this is perfectly okay. I don't have a b here, which means my b is 0. So my first point, easy enough, is right at the origin, at 0, 0. So my rise is 1, so I'll go up 1, and my run is 2, so I'll go over 2. Up 1, over 2. Because I'm running out of room here, I can go down 1 and to the left 2 this way. Down 1 to the left 2. Now I can connect all these points. And I have graphed the point-slope form equation. Okay, pause the video if you need more time. Okay, whoops. So, now I have y plus 5 equals a negative sign, or a -1, times x minus 1. So what I can do is I can distribute that negative sign. So I have y plus 5 equals -x plus 1, just changing the signs. So to get y by itself, to get it in slope-intercept form, I can subtract 5 from both sides. So the 5's cancel, and I'm left with y equals negative x minus 4. So I can plot my first point at my y-intercept, which is at negative 4. And my slope is just a negative sign here. So I know when I have just a negative sign and it appears that there's no number, that's the same thing as having a 1. So my slope would be negative 1. Okay? And because negative 1 is a whole number, I know it is over 1. So my rise will be negative 1. So I can go down 1, and my run will be positive 1. So this way. So since I'm running out of room here, I can make all these points going to the left 1 and up 1 in this direction. And there's my line. Okay, pause the video if you need more time. Okay, so now we have two standard form equations, and we know that because our x and our y's are on the same side. So for this first one, I will use the slope-intercept form method. So I will just solve for y. So if I were to solve for y, let me rewrite my equation. I have 4x plus y equals 1. If I subtract 4x, I can get y by itself. So 4x's cancel. I'm left with y equals negative 4x plus 1. Okay, so now that this is in slope-intercept form, I know I can graph this. So first I'll start with my y-intercept, which is plus 1. So I'll go up 1, make my first point. And my slope is negative 4, so that means I can go down 4, 1, 2, 3, 4, and over 1, 1. And in the opposite direction, I can go up 1, 2, 3, 4, and over to the left 1. And now I can make a nice straight-ish line going through those 3 points. Okay, now for the last one, I'll use the Jake's method for this. So I need to find my slope, which is negative a over b. So I know my a is 1, my b is 5, and my c is 20. So my slope will be negative a, which is negative 1, over b, which is 5. And my y-intercept, which is c over b, will be 20 divided by 5, which 20 divided by 5 I know is 4. So this means I will start at positive 4, my y-intercept. So I'll go up to 4, I'll make a dot, or my point. And my slope is negative 1 over 5. So my rise is negative 1, so I'll go down 1, and I'll go to the right 5. 1, 2, 3, 4, 5. Because I'm running out of room in this direction, I can also go up 1 and to the left 5. 1, 2, 3, 4, 5. Now I can connect these 3 points. And that's how you graph all 3 forms of linear equations. So at this time, I would go to the A2 practice for graphing linear equations, A, B, or C.